I wanted to show you PTable.com. So that's just PTable.com. Very easy to put into your browser. And it's got everything. And I waited to show this to you till we got to the point where it's super useful. So there's a general layout, shows you all the names, shows you kind of where they're at, which is nice, metals, non-metals. Shows you what their different phases for, like, this is, you can set the temperature whatever you want. So you can see what the phases are. But what's really nice is when we get to properties. So right now, when we're talking about all of our different properties, periodic properties and trends, so we can look at, so radius would be the one we've talked about, size. You can see that the largest size is in dark green and the lightest size, but not only that, you can actually see what the value is. And so you can go and check and say, okay, well, Dr. Wren said that magnesium is smaller than sodium, so sodium's 190 and magnesium is 145. So you can go and check, and it's just go across a row. So let's go across row 2, boron. We see we're getting smaller and smaller and smaller. So you can do this for the atoms, and not for ions, but it's a very nice way to just check what you're doing, and there's a nice visual trend. We can also, I should point out, just so you know, there's multiple ways in which we can calculate the radius. We have a van der Waal radius, we have a measured empirical radius, we have what we call covalent radius. So there's lots of different ones. So if you ever see any differences in actual stated values, it could be depending on which value is being used for their size. But if you are using the same value for all of the elements, they should be consistent, bigger or smaller. That should remain the same. What you'll also see is we can look at electronegativity. We can see how the trends in electronegativity, where we have, well, we really haven't talked about that. Let's look at ionization energy. That's a better one to look at in terms of trends. So we can look at ionization energy. This is your first ionization energy. You can go up to the 24th, apparently, for those big atoms in your life. But for the first ionization energy, we can see that we have trends going towards helium on the way to cesium. And we can see these trends as we move along the periodic table. The other one we'll look at is electron affinity, which doesn't quite have the same types of patterns that ionization energy does. So we'll talk about that as well. And you can look at boiling point, melting point, lots of things. So that's the first thing, periodic trends, very nice, especially for radius, ionization energy, and electron affinity, the three trends that we focus on. And what's really nice is looking at our energy level diagrams. So this shows you everything. This is amazing. So let's look at silicon, for example. Well, let's look at carbon first. So we can see that right here, if we click on carbon, then we can see its energy level diagram. So it's 1s, 2s, 2p. And now it's showing you what each of these orbitals, atomic orbitals, looks like. And it's very interesting. So if you go down to like arsenic or something like that, now you can actually see the nodes in our different orbitals. So we can see the different orbitals that we drew, but we can also see how we've added more nodes. So if you go for like nitrogen, for example, and then you go phosphorus, you can see there's a node, and now we've added an extra node, and an extra node, and an extra node. And as we go along, you can't really see them in that angle, but you can kind of see we're adding extra nodes as we move down because the n value is increasing. So it's a very nice visualization of our different atomic orbitals. We also see that we have our expanded electron configuration for each of these. And I'll note that if let's check to make sure we have the exceptions. So for copper, we can see that it has the 4s1 3d10. Now, PTable does it differently than I do it. I always put the 4s on the end. Either one's fine, but we can see the exception is also here, where we have the s1d10. Come to chromium, we have the s1d5, and the same is for molybdenum. So it shows the trends and the exceptions to those in the specific case of d4 and d9 elements. So super nice, shows you visualization, does your energy level diagram. It's a great way to check. So you can basically predict any of these and then go check here to see if you either got the energy level diagram right or you got the electron configuration correct. And if you go back to properties, it'll actually, let's see, I guess I saw it somewhere. Maybe not. Right here. It shows you the condensed electron configuration. So they don't have enough room for the full configuration, so you can actually check your condensed configuration if you want for any of the elements as well. So lots of information. Definitely check it out. And the last thing I want to show you, well, two things. One is isotopes. It shows you all the forms of isotopes and their half-lives and things like that, which is pretty cool for each of the isotopes. And then the wide periodic table is, it actually shows you what the periodic table would look like if you put the lanthanide and actinide series in the periodic table right here versus if you put it down below. So I think that was actually also a very nice thing that you can kind of see how it fits in there. So anyway, that's PTable. Definitely check it out. It's a great study tool, and it's just a good thing to bookmark in your browser.